Yes, welcome to our online class. Today we'll be taking an example on formation of differential equations. And our example here is to form a differential equation from y equals to exponential to the power of x into bracket a cos x plus b sin x. Now, before I begin anything, I have to open this bracket. So I'm going to have my y to be equal to exponential to the power of x a cos x plus exponential to the power of x b sin x. So now from here I have been able to see that I have two constants here, and my constants are a and b. So y equals to exponential to the power of x a cos x plus exponential to the power of x b sin x. So it means I'm going to differentiate this equation twice. Now let me do the first differentiation. So if I differentiate y with respect to x, I'm going to have the y, the x equals. Now you can see that I'm going to use product rule because my exponential to the power of x and I have a cos x. So you have to be very careful while doing the product rule. You don't have to be extremely careful because I know you know it. So if I keep exponential s constant and I differentiate a cos x, I'm going to have negative exponential x a sin x. Now I'm not going to keep cos s constant and differentiate exponential s. So I'm going to have positive exponential s a cos s. Now I'm going to do the same thing this side. If I keep exponential s constant and I differentiate b sin s, what will I have? I will have positive exponential s b cos s. Now if I keep b sin s constant and I differentiate exponential s, I'm going to have plus exponential s b sin s. Now you can see that in my equation I have y equals to exponential x equals x plus exponential s b sin s. Now if I look at this very closely, I will see that I have something similar. I have exponential s equals x and exponential x b sin x. So these two will represent my y. So I'm going to have the y, the s, to be equal to, so I'm going to write exponential x, exponential to the power of x a cos x plus exponential to the power of x b sin x first, which is my y plus, let me write this first, exponential x b cos x minus this, minus exponential to the power of x a sin x. Now I have written that. Do you know that I can now do something? I can now make my exponential s b cos s minus exponential s a x a sin s to be the subject of formula, because by the time I differentiate it the second time, I want to eliminate a and b. I told you I don't like constant while I'm forming my differential equation. So it means I'm going to write this as exponential x b cos s minus exponential x a sin x will be equal to what? The y dx minus y. You know, if I bring this to this side, but because I want to make them so it's formula, I bring them to the left hand side. So I have this. Now I will not go back to my equation. This, the y dx, this derivative, because I have to differentiate this for the second time. So from here, I'll differentiate the second time. The derivative of the y dx is the second derivative of, that is this squared y the s squared equals to. So I'm going to use, you know, here I'm going to use product rule to differentiate the whole of this. So here I have the y ds. I've done that already. That is d squared y over the x squared. Now I've done that already, so I have to begin to treat this one after the other. Now I know you can do that. If I keep negative exponential x constant and differentiate this, I will have negative exponential x a cos x. Now if I keep a sin x constant and I differentiate negative exponential x, I'm still going to have negative exponential x a sine x. Now I'll do the same thing to this side. If I differentiate a cos x and I make exponential x constant, I'm going to have negative exponential x a sine x. Now let me keep this a cos x constant, differentiate this, I will have positive exponential x a cos x. Right? Now come to this side, keep this constant, differentiate this. I'm going to have, it's very interesting, exponential, sorry, this is cosine, so I'm going to have negative exponential x b sine x, so you have to be very careful. Now if I keep this constant and I differentiate this, I'm going to have positive exponential x b cos x. Now I'll come to the last but not the least here. So if I differentiate this and I keep this constant, I'm going to have positive exponential x b cos x. Now keep this constant and differentiate exponential x, I'm going to have positive exponential x b sine x. Now all these I have done, do you know that there's one particular thing you have to observe closely, that if you look at this second derivative, remember that we said our y is equal to exponential x a cos x plus exponential x b sine x. Now if you look at these two, if you look at this, look at what I'm going to do now. I have negative exponential x a cos x here, and I also have negative exponential x b sine x. So these two is negative y if I add them together. Do you know that? So I have this squared y over the x squared to be equal to, this is negative y. Now again look at it very closely again. Since I said this y is exponential x a cos x plus exponential x b sine x, now look at it again. Exponential x a cos x, I have positive exponential x a cos x, and again I have positive exponential x b sine x. That is what? Positive y plus y. Now do you know that why we make this one subject of formula, exponential x b cos x minus exponential x a sine x to be equal to this? If you look at it, you are going to see this here. Now exponential x b cos x, this is this, let us put a circle also, this is exponential x b cos x minus exponential x a sine x. They will marry each other. Now I have positive the y over the x minus y. Again I have this positive exponential x b cos x, negative exponential x a sine x. These two will marry each other, instead of expanding the whole thing. So I already know that is another what? Positive the y the x minus y. So it means that if I solve this, my d squared y over the x squared is equal to this, we cancel this. You know that the y dx plus the y dx will give me 2 the y over the x. Negative y will give me negative 2y. And I would like to write my equation to be equal to 0. So I will have the squared y over the x squared. If this one comes to this side, it's going to become what? Negative 2 the y dx. And if this one comes to this other hand, it will become positive 2y, and that is going to be equal to 0. And that is the solution. So that is the solution. So that is very, very good. You know that the deal is that you must be happy, I must be happy, we must be happy. So remember to subscribe, comment, like, and share. Thank you very much.